Hi, welcome. So today we are going to look at what a data analyst does compared to maybe what a data scientist does, and also the skills that are needed to become a good data analyst. I know the companies are not making it easier by the fact that there are some job descriptions that mention that they need a data analyst, but at the end, the data analyst is doing more of data science work, or they need a data scientist, and at the end the data scientist is doing more of a data analyst work, or they need a data analyst and at the end the data analyst is doing ATL or data engineering work. So let me just try to break that down in this video. And one of the things I think personally is that as a data analyst, you're kind of like maybe in the making of becoming a data scientist. It's easy to become a data scientist, but then it's another profession on its own, data analysis on its own, data science on its own. But then if, for example, you're a good data analyst and then you pick on maybe some machine learning, for example, then you can already start moving towards data scientist kind of a role. So if we look around us right now, it's a fourth industrial revolution, and data science is just about everywhere in almost everything we do. So for example, when you're searching something on the internet, your internet searches, you would already see that it's trying to complete that search for you. So it's something that Google, you see it on Google on these search engines. The next thing you can see data science everywhere is speech processing applications. Like when you look at your things like Alexa, Siri, you ask a question, they are able to respond with some prediction of what they think is the answer you need. And then also if you have been buying maybe some products on maybe sites like Amazon, you will see that there are some product recommendations. Those who bought this also bought this. On YouTube, when you watch a video, there are some recommendations on similar video like this, or on Netflix. If you're watching a movie, there are some recommendations for movies that are close to this one, and most of the time it's actually the recommended movie is really what you'd like to watch, kind of. So these are just applications of product recommendation. Another one could be on sites like Meta, Facebook. You maybe get a suggestion, a friend suggestion, and said maybe this looks like a friend you might know, or things like that. So these are just recommendation systems that are all over the place, and we don't even see it. And also for gamers, if you're a gamer, you would notice that the games, modern games, are kind of like using reinforcement learning, which is an example of a machine learning task, which the game learns and improves as you play. So the first few levels are easier. There is the game doesn't really know much about your strategy, and it's learning, so that by the time you get to higher levels, the game is learning your strategy, and then you're able to like you need to change strategy to be able to outsmart the game, and it keeps it interesting. And also on chatbots, we can't ignore the fact that ChatGPT is an example of a chatbot that has like disrupted the internet. So it's an example of a chatbot that is one application that data science is everywhere now. Let's talk about the analytics process. So this would be able to help you understand what clearly the data analysis is supposed to do, and then from there you can also be able to know maybe what the data scientist is supposed to do. So the first thing is problem framing. So being able to understand the problem clearly. What problem are we trying to solve? Because remember, a problem well shared is half solved. So you're able to understand these are the KPIs that we want to improve on. This is the real issue. So for example, you could be in a setting where the meeting is about, let's try to solve the problem of sales. In maybe the sales team is not doing well, but in reality, when you do your analysis or root cause analysis, or ask your 5 whys or things, you might understand that the problem is actually coming from the logistics team, who is not able to provide the sales team with the devices that they have to sell. So this is an example of how you need to frame the problem correctly, because with this framing, it can disrupt the agenda of the meeting and really improve and better position that better provide a direction and even something more efficient for the company. So professions like consultancies and maybe other project management meetings like this, usually have this in common, where they try to identify the problem clearly from day one before everybody moves to put in any resources or any maybe timelines, and also knowing the stakeholders. So this is something that is very, very important, and it's really going to help to save a lot of costs down the line. Then the next thing is, after you have been able to identify the problem clearly, and then now you define the KPIs that will be measured and things like that, now you need to go collect the data. Say, for example, you want to open up a new branch of the company in another city. You want to understand, collect data like, what is the population of that city? How many maybe schools are there? Are there any gas stations by it? Or what is the traffic, the footfall around that area? So things like that, you'll be collecting the data, and the data could be structured data, semi-structured data, unstructured data. It could be tweets, it could be videos, it could be likes, it could be shares, it could be text, it could be audio. So you're going to collect the data necessary to solve that problem, which has been defined in the first step of the problem framing. Now, the next step is being able now to clean that data, because the data doesn't come exactly as you want it to. Maybe some secondary data that you collected for somebody who was doing some other research for some other reason, and then you might need to adjust it or customize it to your taste. So you need to clean, maybe there are missing values, empty, some columns are empty, and then also you might have some missing values at random, missing values non-random, or missing values with information, missing values without information. And then you might need to do some mean imputation or median imputation, or there's lots of things that you might need to do to clean the data. There might be many outliers, and you might need to handle the outliers by binning, or there are many different things you can do. So that's just to clean the data. Then now you've cleaned the data. The next thing now is to start exploring that data to be able to find out, get interesting insights or correlations or hidden patterns from that data, to be able to solve the problem. So you might find out, okay, are there any patterns with maybe shops that are located by schools or by supermarkets have been performing well? So you're using now that exploratory data analysis to test your hypothesis, to be able to come up with clear some hidden pattern, and then maybe orient the business towards that direction. And then at the end now, you build now a dashboard or some visualization or something to be able to summarize all of that, because humans are visual. A picture is worth 1,000 words. So you build something like a visualization of what you have done to be able to show the management. So if it was a data scientist, the data scientist would, after the exploratory data analysis, be doing maybe say some feature engineering and then building a model to be able to predict something. But then as a data analyst, you might, your strength is not the model building, but more of that visualization, that dashboard, that thing that you would bring to the top management to be able to see what you see and tell the story. And then now, after that, I just add another step on that, is being able now to provide recommendations and action plans. Okay, what do we do? What's the next step? What's the way forward? And they're probably maybe following up on those action plans. So, but then it's just that's really like showing you where the data analyst would orientate more towards than where the data scientist would move towards. So now let's talk about the different types of analysis. These two might help you know clearly what is expected of you as a data analyst. There is the descriptive analysis, which is the what. There is the diagnosis analysis, which is the why. There is the predictive analysis, which is what would happen. That's now the future. And then the prescriptive, which is now how it should happen. So now things like that are like the kind of analysis you should be aware of. And of course, there is the exploratory data analysis, which I talk about it at the end. So the first descriptive analysis is more of like what happened in terms of like, that's where you use your statistics, your mean, your median. What is the sales of per region for the past 1 year? Then you would see that there is a region that is performing better, the north is performing better. So it's the what, it's more of historic data, what happened, but there's no why. why it happened is the diagnostic analysis of, okay, why is it that the north is better than the south all these years or in certain months? So for some reason, maybe there was snow or there was rain or there was whatever. So that's the why. Now you're trying to produce a report with the what happened and the why it happened, so that people can be able to act upon that insight. Then now for the predictive analysis, it's more of like predicting maybe the sales for the next couple of months. That is where now there's that separation between what the data analyst does and the data scientist does, because the data analyst is not expected to do much of the predictive analysis than the data scientist. So that the data scientist will learn some machine learning and is able to predict maybe the sales for the next quarter, while the data analyst will be more focused on the visualization, like we said. So the next thing now is a prescriptive analysis, which is more of optimization. There's the predicting of the future, but then what is the prescription to be able to solve that, like just like the doctor's prescription. This is what I think you're sick of, and to prevent you from falling sick further, this is the prescription. So that is an example of prescription. And like in airlines, trying to optimize the paths. Maybe this plane will carry this number of first class, do this stop here, and then drop this off, carry this number of third class plus this first class, do this next stop here. So it's mostly solving optimization problems. Then the exploratory data analysis, which is very powerful, is being able to identify patterns that are hidden in the data. I'll take the example of a deep sea diver or an explorer who goes in water and is trying to discover if there's any new species of fish or any new species of maybe sea plants. So it's able to look at, okay, maybe I've seen something yellow at that angle. Let me zoom in or go closer, swim closer and see, explore and see, okay, no, it doesn't look interesting. It's something we already know. Then maybe I have another angle, I've seen something blue. Let me zoom in or go closer, use my statistics skills and all that to see. And then, wow, I found something interesting. Come on the surface, book a meeting, and tell your management or your partners or your shareholders or your colleagues, this is what I found out, which can maybe improve on our revenue, reduce cost, or improve on processes, or completely disrupt our strategy. And there are many examples where the explorative data analysis has been used to disrupt companies and change strategies and make things better. So if you want to summarize or get to 8 is 1, there's the descriptive analysis, which is the what. There's a diagnosis analysis, which is the why, and the powerful exploratory data analysis, which is more of you trying to come up with hidden patterns. And then for the predictive, is more of what the data scientists would do, and prescriptive, machine learning, and data scientists. Those are the core things to know about the analysis for a data analyst. So what do companies really want from a data analyst? So if you follow through, you would see the first thing would be data cleaning. You are needed to come help clean the data, because the company might be sitting on petabytes of data, lots of data, and is not able to clean that data for maybe other departments to use, or just to generate insight or information from that data. So data cleaning is something you bring on the table. And the next thing is exploratory data analysis, pattern discovery with your exploratory data analysis. So being able to come identify some hidden patterns, some correlations that maybe nobody had noticed before, and being able to come up with some disruptive idea that could pivot the whole business or change the strategy, or some way of just improving revenue, reducing costs, or improving efficiency. So your exploratory data analysis, like we explained before, is able to help you come up with some hidden features or some hidden correlations that nobody has seen before. Then they also need your data visualization skills, because story is worth 1,000 words, picture is worth 1,000 words. So your storytelling and your data visualization skills will be able to summarize those millions of rows of data to just one single pie chart, which shows maybe the proportion, distribution, and things like that. So with that data visualization and storytelling skills, you're able to clearly give lots of impact, because many people don't have that skill. And then of course they will need you to create dashboards and be able to, they have identified a couple of KPIs, and they want to monitor them maybe every Monday or every day at 8 a.m. or at 6 p.m. or whatever. So you come up with interesting dashboards so that the trends can be observed. What is the year on year for this KPI? What is the month to date? What is the month on month? All those kind of comparisons and analysis, and also produce performance reports, because you might be doing like PowerPoint reports or any form of reporting, but maybe you could be in charge of the operations report, being able to tell the performance for the past period, the past month, the past year, or actual versus budget, and things like that. Now, let's talk about the skills. What are the skills needed to become a data analyst? We will go into detail these skills in subsequent videos, how to acquire them, like the steps. But then one thing you need to know about the data analyst career is that the soft skills are more important or equally important like the tech skills, the soft and the core skills. So for a data engineer, for example, there will be more on the stress on the tech skills, being able to be a very good programmer, being able to harness large volumes of data, let it be fast enough, let it be stored at the lowest storage possible, and things like that. But then for a data analyst, it's more of soft skills as well as the tech skills. So the first soft skill to have is like business understanding. For you to be able to use that powerful tool, which is exploratory data analysis, you need to be able to understand the business, understand what is important to them, understand what management would value, like the new insight that you just found out. Say you were underwater, you discovered that new fish or that new sea plant, and you're coming to share with them because you know what it would mean to them to have that discovery. So it's business understanding. And again, these soft skills, we are going to teach you in subsequent videos how to acquire them, the steps to be able to acquire them. And then the next skill is basic maths and statistics, which is mostly high school maths. Don't be scared. It's not complicated mathematics for data analysts. Maybe for data scientists, you might go a step further with your statistics, but then for a data analyst, it's just basic mathematics, could just be simple arithmetic, algebra, so not too complicated. High school would have covered this for you. We are still going to go into detail in a subsequent video. And then also logical and analytical thinking, because just being able to come up with a business problem and being able to think critically, like the 5 whys, the root cause, what is really the problem we are trying to solve, are we really on the right direction, or things like that. It requires some logical thinking and some analytical thinking, which again, of course, we are going to show you how to acquire that in subsequent videos. And then the next thing is communication, because with your data visualization skills, your storytelling that is required from you, you need to be a good communicator, both written and verbal, so that you are able to express maybe what you found out. Say from that, your exploratory voyage, again, you came up with something interesting. You need to communicate that to people so that they can act upon your proposal or your recommendations. And of course, one of the key things you should remember is that you're a problem solver. No matter what tool you use, no matter what technology, you're there to solve problems. That's why the first step in the analytics process is problem framing. Frame the right problem, because at the end of the day, we just want to get that problem solved. So that is the soft skills that you would need before the technical tools like Excel, SQL, Power BI, Python, and all those other things, which will train you in this in subsequent videos, as well as these soft skills on how to acquire them in subsequent videos. Okay, so now that you have a clear understanding of what the data analytics professional is supposed to do, let's try to clearly show you the 4 deliverables so that you can be able to draw again a clearer line between what a data analyst does, what a data scientist does, what a machine learning engineer does, and what a data engineer does. So I'll just show the 4 deliverables. Of course, they are not, each company is different. The size of the company, the stage of the company, the project. Sometimes you do this, you're doing some data engineering at the same time, data science, but then it's just for us to be able to clearly distinguish between them. So the first deliverable is building dashboards and reports, which you must have noticed belongs to the data analyst. That's like what is expected of the data analyst. And then the second is using machine learning to build maybe prototypes, like being able to forecast the sales for the next quarter, not necessarily going on production on a live system. That is what we expect of the data scientist, because he's using some of the data analytics skills that he knows to do the collection of the data, cleaning, exploratory data analysis, but at the same time using some machine learning models or machine learning techniques to be able to predict with data from internal sources or external sources, data scientists. Now, the third is being able now to build maybe AI applications, machine learning applications that are running live, maybe monitoring them even if they are still performant, learning, retraining the models, being able to track if there's a model drift or data drift or things like that in real time. And is it scalable? Is the application secure? Is it robust? Can it handle millions of requests? So that is what now the machine learning engineer would be doing, which is different from what the data scientist does and the data analyst does. And then now the fourth is mostly using like ETL ETL is extract, transform, load. Data engineering now is mostly using ETL, extracting data from maybe the databases, the different databases, maybe from an ERP system, from your CRM, from different sources, and then transforming them, then loading them to one maybe data warehouse or one data lake where the data analyst or the data scientist can come take from there, build the dashboard in the if it's the data analyst, or build machine learning models if it's the data scientist. So I hope you get that clear distinction. So if we have to summarize it or look at it clearly, the data analyst and data scientists do almost similar things, from the problem framing, data collection, data cleaning, exploratory data analysis. Where they differ mostly is while the data analyst branches out to build data visualization dashboards, the data scientist is branching out to build models to predict, and mostly prototypes. There's not too much of software engineering behind it. There's not too much of DevOps. While on the other hand, now the machine learning engineer could even take a model that the data scientist has built, which is interesting and is struggling with, and then fix it, deploy it now on a live system, being able to follow up, make sure it respects software development principles, and then the DevOps is right. And that's why roles like MLOps entail DevOps, machine learning, and also data engineering pipelines, because if your data is fast or big data, you have to treat the machine learning models differently. If the data is small or whatever batch, is it real time or batch, you have to treat it differently. So the machine learning engineer is at the front, supplying the applications to the end user in real time and making sure that the applications are secure and they don't the predictions don't change over time. So hope you are able to understand these differences. We are going to teach you all of this throughout the program. Now you know the difference with the focus on data analysis, and hope now you know clearly what is expected of you. And again, as a reminder, soft skills are important, and also the roles might be different based on the company, the stage of the company, the country, the size, your team members, what they know, what they're currently using. There might be very different requirements from you, but now you know clearly, ideally, what a data analytics professional is supposed to do. So see you next video. Wish you good data luck.